Hello everyone and welcome to part 2 of the Recitation 0L debugging. In this recitation, we are going to be talking about three types of errors, which is the coding error and errors which can occur due to the time issue and then the memory issue. In coding errors, we will mainly be looking at syntax errors, logical errors, and errors which occur due to mathematical multiplications going wrong, and runtime errors. In the type 2 time issue is when some of your epochs are taking too long, and in the memory issue is when you have your CUDA going out of memory, which is common when using GPU to train models, and figuring out the location of variables and where to put them in order to run them appropriately on a GPU. This recitation, we will cover error type 1. In error type 1, we have three different types, the first of which includes the syntax errors. Here, your best bet would be to go to Stack Overflow because most of the errors that we STAs encounter can be first debugged using Stack Overflow because many users would have faced the same thing before. Since all of our code pretty much is going to be written in Python, please refer to Recitation 0A, which is important, which speaks about Python and OOP fundamentals. Now, the next type of error would be logical and mathematical errors, wherein you have a lot of matrix multiplication and math, particularly in part 1 of the homeworks. Here, the main important thing would be to go through the write-up carefully. We have spent a lot of time in building each and every write-up of every homework, and they have examples which are accurate and can be used to debug your way through the different matrix multiplications that can happen. Now, particularly in homework ones, you want to check the dimensions, the shapes of the variables before coming to a conclusion that your error is this is what it is. And if you can debug that, if you can look at the shapes of the variables, that's most likely to be where your error can be. Now, using the write-up, you can write it out by hand and debug that to figure out where you might be going wrong in the dimensions in the matrix multiplication. It's easy to get overwhelmed, but NumPy has fantastic documentation for each function that you use and it would be useful to check this using Stack Overflow or any other source you can find for the purpose and its input types and the output types, as well as the shapes. This can help you in figuring out which shape of the variable works and which does not, and can help you debug these type of errors wherein you have a lot of matrix multiplication. The next type of error, the last type of error here, would be the runtime errors. Now that we fixed some of the errors that can happen when you're compiling the errors, you want to look at some errors which can happen. You might encounter some errors that can happen when running your model. And in this, you want to look at the traceback to find the root of the error, because by first glance, by just looking at it, the compiler will not throw you an error only when you run the program. Read the library documentation for different function specifics, and some of the times the GPU will not return the error for you. In this situation, the thing to do would be to set the batch size to 1 and run the code on CPU. This will give you a more readable error message and help you to debug your code. Now, this is one of the most common errors that we have seen in past iterations of this course. And switching to the CPU and so that you can understand where the error is actually happening is a useful tool. Now, PDB is a very useful and functional tool, which we will go through right now with a demo. Before that, I want to mention again that Stack Overflow is a really good source for debugging most of the errors that you might encounter. So this notebook, the link of this is there in the video description, which you can use in order to go through this recitation. Here, the main purpose of this notebook is how to read the traceback and how to use PDB for interactive debugging. Most of the time when a Python script fails, it can raise an exception. For example, in this code, I've defined a function 1a. If you run this code, it will show you that it is a division by 0 here. One of the good things about Colab is that you can actually expand these frames to see where the error can happen. When you click on this, it opens a cell on a tab, and you can actually edit your code here in order for you to enable you to quickly fix your code and directly lead you to where the error happened. So this is a useful step that has been given in Colab. Now you can also search Stack Overflow for such an error, as I just mentioned. Now, here is an example of some errors you might encounter while writing deep learning code. Now, you might need not know about this particular, what each of these functions do so far, but the main idea is to generate an error traceback in order to demonstrate how to use PDB in order to debug it. Now, here we have defined, you do not need to pay attention to what these are right now. Now, when I run the loss, it shows me that I have this as the runtime error, 0D or 1D target error expected, multi-target not supported. If you would expand your frames, you see a lot of jargon here, which is in internal Python code. And you see that it might look very complicated, but this is nothing to be afraid of. Most of these libraries here you can see are from PyTorch, or it can be NumPy in some cases. So when debugging, you do not need to pay attention to this part of the code from here, because you can assume that the Python code works without any fault there. What you need to look at is your code that you have written, which is here, which is the last frame before which it went into the Python calls. So your error is most likely to occur here in the recent frames. Typically, you can probably look at the most recent 2 to 3 frames to figure out where you might be going wrong. The quickest way, as I mentioned, is to look at Stack Overflow, and some of us TAs also use that pretty intentionally. Now, let's look at how to use PDB in here. Now, let's say I call this function, again, the same function that was saying division by 0. The most convenient interface here for PDB is that using the %debug magic command. If you call it after hitting an exception, it will automatically open an interactive debugging prompt. Now, what do you mean by interactive? It lets you step through each code line by line in order to see what might be causing a more difficult error. The PDB prompt lets you explore the current state of stack, explore the available variables, and even run Python programs. Now let us go through an example here. When you type %debug, you can see I open an interactive box here wherein I can type input. Now if I type print A, BA, I can print the value of A, and PB prints the value of B, and I can see that B is 0, which is what is causing it, and I will quit right now. Now, this interactive view allows much more than this. We can also step up and through. For example, here, if I type up, it goes to the upper frame where the function 1 was called from function 2. I can go up again to see where function 2 was called. This helps you identify where the traces are and where you might be going wrong. Now, you can also specify a number after up or down in order to go up or down more than 1 frame at a time. Now, here, if you press down 2, you can go back. We again go back to function 1 of A comma B. Now, this is very useful when you're writing complex long code, and it can be a fantastic way to identify where you might be going wrong. Instead of calling the debugger after the exception has occurred, you can also in the cell that you can also specify %PDB on in order to raise the exception, in order to raise the debugger whenever you have a division by 0. Finally, if you want to monitor the behavior of your code in an interactive mode, you can add a breakpoint within the line and use set trace using the command, and use the next command to step through the lines of code interactively. Sorry, there was a mistake there. So here you can again print A, B, and also quit. Now, if you want to monitor the behavior of your code here, as I said, as you all know that in the previous part of this recitation, we worked through how breakpoints might work. Here, pdb.setTrace adds breakpoint within the loop, and it works similar to how you would use it in any other code editor. And you can use the next command to step through the lines of code interactively. Now, it will stop at every time a debug breakpoint is occurred, and basically you can use the next command to step through the code's lines of code interactively, which is useful in when you're trying to figure out where the variables might be and see what is happening in the code. So if I press next, it goes to the next command, or if you can press C, it goes until the next breakpoint is hit. As you can see, it has gone through the next loop. Finally, here I have given a list of current commands which are there, which are always updating, which might be useful in using PDB and debugging your deep learning programs. Thank you and I'm Harshit and look forward to part 4.